This spy board started as a simple idea, but I wasn't satisfied, so I rethought everything, rebuilt it from scratch. In this new version, I have added a TFT display, a Raspberry Pi camera module, redesigned the wheels, upgraded to 12-volt gear motor, a completely new design. Let me show you exactly how I did it. And just like before, the entire wheel is fully 3D printed, and this project is fully open source. Every still file, link in the video description. Now, a lot of you ask me what filament I use. For this build, I went with Newmaker filament. For 3D printing all the parts, I am using the Starlight Neptune PLA. And no, this is not sponsored by Newmaker. I printed all the parts, the chassis, the wheels, the front and back extension, wheel coupler and the top cover. Well, if you don't have a 3D printer, no problem. You can visit In3D Tech. They are also sponsor of this video. In3D Tech help engineers, startups and manufacturers bring their ideas to life with advanced digital manufacturing. They offer 3D printing, CNC machining, injection molding, vacuum casting, sheet metal and die casting, carbon fiber and 3D scanning. Why choose In3D Tech? Because they offer wide range of capabilities, fast prototyping, affordable pricing, engineering support and most important, quality assurance. Ordering is super simple. Upload your CAD file, get code, manufacturing will begin and parts get delivered to your door. I uploaded my wheel part and here you can see you can view it in 3D. Select the quantity, confirm your order and it gets delivered straight to you. Use this coupon code and get extra 6% off your first order. Link in the description. Go upload your design today. Back to the wheel. First thing, brush insert. They are what hold the whole body together, so don't skip them. I'm using my soldering iron to press in M3 brush inserts, 8 on the top of the chassis and 6 on front and back side. It takes a few minutes, but it makes a huge difference in how solid everything feels. And here I'm using 12 volt 100 rpm gear motors. Fitting them is simple. Remove the knot and we need 4 of them. Remove the knot, slide the motor through the hole of the chassis, then tight it back so it locks firmly to the chassis. All 4 motors are now attached. I have changed the wheel structure so each wheels get 4 M3 brass inserts pressed in plus another one wheel coupler, that's what connect to the wheel to the motor shaft. Once the inserts are in, align the coupler with wheel hole and lock it down with 4 M3 LNK bolts, and I will do the same with rest 3 wheels. Now simply slide each wheels in the motor shaft and tight the M3 bolt through the couplers to lock it in place. Before moving on, I did a quick test, connected 12 volt battery to check the motor direction and speed. Everything worked perfectly on the first try. And in the front extension, it has 6 holes for 8mm LEDs and a slot for Raspberry Pi camera module. I am placing 4 white LEDs and 2 warm white LEDs. After pressing the LEDs, I will mount the RPI camera module into its slot and fix it with 4 screws for a tight fit. Now I will complete its wiring and later we will connect it with the chassis. And in the back extension, it has power section, power switches, XC60 connector, DC jack, voltmeter, rail LED, and another module and Wi-Fi antenna. So I will place all the components one by one. Here is the full wiring diagram. I will connect all the components including this front and back, both the extension, motors and motor driver and ESP32. First I will wire the motors with motor driver. Here I am using L292 and motor driver. Once it completed, I will place it in the chassis. Next, I will wire the front and back extension with ESP32 and the motor driver. It may look little messy, but if you follow wiring diagram, it actually very straightforward. I am also planning to design a custom PCB for this to clean up all the wiring. Power, here I am using two 3S lithium-ion battery packs, one for the motors and one for the electronics. And the reason why I am using two different battery packs, when there is a load or spike on motors, it will not affect on the logic side. Now all the wiring is completed. All we need is to connect the board extension with the chassis. So here I am using 12 M3 bolts, 6 for the front side and 6 for the back side. After programming the ESP32, I will press the top cover and screw it with 8 M3 bolts. This video is getting pretty long, so part 2 is coming soon where I will show the robot action, testing, demo and few more upgrades, and I will show you couple of more upgrades that I am testing. And if you have been thinking about getting parts made without a printer, seriously go check out In3D Tech, link in the description. See you in part 2.